Og det ser ud til at være hul igennem. Hej til jer alle sammen. Tester lige lidt lyd, og det hele lige kører, inden vi starter. Så der er stadig en 10 minutter endnu til officiel start. Oh, and of course, this is in English. So it was just a sound test. The talk will be around an hour, plus minus. And hello, Jonas. So now it's about 17:30. We'll just wait for the last few people to come in. All right. So I think most people are tuned in now. We'll just let the last few people come in. While I'll transition here to the presentation. I'll be talking about Angular and React today. I'll try to not pick sides here, and I don't think it's a I don't think there's a clear winner. Just as a preface here. So, but I'll still just explain some of the pros and cons of Angular and React, and then when to choose each of them. So the agenda for this tech talk is going to be a short introduction, and then I'll explain what is Angular, what is React, what are some of the technical similarities and differences in them, and then I'll talk about how to for both Angular and React, how you can get started, how you can set up a proper structure or architecture of your application, and how you can optimize it for performance as the application scales up. And then of course I'll give some comparisons, pros and cons, and how you can best choose which framework is the best for you or library. So my name is Christian Sederqvist. I'm a senior interface specialist here at Netcompany. I've worked in the UI department for about 4.5 years now, and I graduated from ITU studying software development and technology. I've worked on Angular and now also React project for most of the time. Most recently, I'm working on a React project. And my focus has been on performance and building large web applications. So Angular is it started out as something called AngularJS, which a lot of people really didn't like, and therefore it was revamped as Angular. Currently it's at Angular 9, and it's sort of a framework that tries to provide you with everything you need. Everything packed into one framework, as they put it. So the functionality for components, forms, dependency injection, routing, everything is gathered in one place in Angular. Yes, it will be possible to ask questions during the talk. I'll pause in between some of the sections of these slides and just check if you guys have any questions, and I'll also check up on you at the end of the presentation to see if there's any interesting questions. So Angular sort of tries to provide you with all the tools you need, which, if you look at React, it is on the other hand just a rendering library. It doesn't even claim to be a framework, and then you have to either make your own cocktail of libraries as you go along, or you can write it all out yourself. Usually there are some very regular stars in a React project, such as Redux or React Router, but there's still a lot to research and look into and mix up when you're doing your React application. And there's also not any unified style guide or best practices in the same way as Angular provides it. You just get the library and sort of, here you go, figure it out. Of course, there's plenty of documentation for the features that it does have, but not really any unified style guide that I could find. And this also gives you much more freedom than Angular, because you do make your own cocktail of libraries, or write them yourselves. But it can also be a bit of a jungle finding the right auxiliary libraries for your application, since you can probably have 2 or 3 different libraries for each problem you want to solve, which Angular sort of doesn't leave you with that choice to make. So some of the similarities between React and Angular is that they both rely on sort of a component system, using input properties and some sort of internal state representation. they are both able to inject data down through a tree of components without passing it through each component manually. You have in Angular you have dependency injection, and you can sort of achieve the same thing in React with contexts. And of course also you can do some similar stuff with Redux. And both of these libraries frameworks have a life cycle concept of the components. So you can sort of build your listeners when the component is mounting, and then tear down your listeners when it's unmounting, and then detect changes and so on. But there's also a lot of differences. React provides much fewer standard implementations, and it leaves a lot of the work up to the community to create auxiliary libraries, while Angular aims to provide everything. And there's also some differences in how it does change detection. So Angular implicitly figures out which objects and fields to watch, and it runs change detection whenever there's a user input or some network or timing event. While on the other hand, React is it only runs change detection when you've explicitly updated the state by setting set state, or by updating a context. But that's we can get into that later. So I'd also say that the React is much more, when you're building a React application, it's much more concise and dynamic than Angular is when it comes to creating a component. And it's really close to JavaScript. So if you look at the two pieces of code here, this info component, it's just a simple function which returns some HTML. So that's a one-liner almost, and you can compare that with a very simple Angular component where the decorator here actually probably takes up more space than this whole function. So you do run into Angular being more verbose, but also more structured. It has a more structured approach to components, and there's a lot of features and ways you can sort of tweak your components. A lot of functionality you don't get in React, but that you might not need either. And of course, Angular enforces the use of TypeScript, while React leaves it up to the developer and lets the community maintain the typings. So you can use so definitely typed is a really good project which brings types to all the different libraries, and it stays pretty well updated with React. So I wouldn't say it's bad or good that it doesn't support JavaScript, as I'm a really big TypeScript fan. And they also have some different rendering performance optimization techniques. React has pure components and memos, which is sort of the same as on push in Angular, where sort of the change detection strategy is isolated into when the component itself makes a change, and not when it's being when something else is updating something. So these are sort of the main differences between React and Angular. There's also some resource loading optimizations. So lazy loading, both of these frameworks support it, but they do it in different ways. React has a React Lazy and Suspense, which lets you in very short syntax lazy load a component and have a fallback or a placeholder component to show while it's loading. Angular does also let you lazy load modules using the load children syntax in your router, for example, if you're doing a route-based code splitting. And it's also impossible to implement placeholders, but it's a bit more verbose, as it usually always is with Angular. And of course, Angular is much more documentation heavy. So now we're getting to the Angular section. Let's just have a look if there's any questions. Yes, AngularJS was very cool when it came out. Yeah, and it was very hated when by the end of it. And sure, I can probably send you the slides after this talk. remind me when I finished here. So setting up Angular is very easy. Despite me saying that Angular is very complicated, you just have to write 3 commands and you got an Angular project. And the Angular command line interface lets you generate everything you need in Angular. So I'll just give you a few tips on when you're building an Angular application, how to set up your structure, how to load your components, how to split up your functionality. And all this is based on the Angular style guide. There's really no need to reinvent the wheel when the style guide tells you all you need to know. It's really a really great resource to refer to whenever you're building anything. If you're ever in doubt about the Angular way, or if something doesn't make sense, make sure you follow the style guide before diving into the jungle of documentation that Angular has. And a lot of this will probably seem like common sense to some of the more technical guys, but it's really good to have a reference for what you're doing, to make sure that you're doing things right. And sometimes you sort of stare yourself blind on things. So one of the main principles in Angular, or in the Angular style guide, is the lift principle, which says that you have to make code easy to locate. That's the L. You have to be able to identify code at a glance. That's the I. You have to keep a flat structure, and then you have to try to be dry. And dry means don't repeat yourself. But it says try, so you don't have to go to great lengths to not repeat yourself, but try not to. And then they suggest you use a folders by feature structure. So you create a folder for each feature area that's represented in your application. And of course, create a module for each feature area and place that in the same folder. And if you use the command line interface, it will do all of this for you. And of course, create a shared module to have shared components in. This will help you manage size, and you don't have to rewrite stuff. And it'll also help you in the future if you ever decide to split out your shared module to more projects. Of course, be mindful of the dependency injection that is in Angular and how it works, especially with services in the shared module. If you import this as you import this shared module in all your feature modules, you'll have an instance of those services in each feature module. So that's something to be aware of. And yeah, so here's an example of an overall structure from Angular's documentation. As you can see here, you have some core functionality. These are some singleton services. And then you have your shared functionality down here, which has some components, a pipe, and so on. And then you have your feature module here. And this is really, really simple. And it tries to stay as flat as possible. And of course, inside a heroes module, you can also have some shared components that you want to reuse across your other components. So the hero list might use the hero button as well as the hero component itself. So shared modules are, yeah, there's not really much to say. You sort of export all the components that you'd like to export, and the ones you don't export are not provided out to the modules that import them. And dependency injection system is really something it's really good to familiarize yourself with as well. It'll help you understand a lot of things in Angular, and it'll also provide you with a really strong tool. So it's not just there to be complicating and annoying, but if you sit down and understand how the dependency injection works, you can build some really well formed code. So you can specify which services to provide in a module. You can override provided further down, so you can provide different instances of a more generic service. And you can also specify for these services that you only want to provide them in a specific module or in the root of the application. So as you build services, the connections to data, for example, in your backend, utilize dependency injection, and let your services have a single responsibility. Don't let them cover way too many things. and provide the service in the root unless you really have a specific need for multiple service instances. And you should also isolate communication with your backend and data retrieval into these services, as I mentioned. So there are a lot more details, tips, and guidelines in the style guide. So do not skip it. Really give it a look and go through it if you haven't already. So as your project grows, you have to be able to handle the increase in size and complexity too. And especially Angular has a big problem with how it grows and the bundle sizes. So I got some points that are focused on sort of Angular specific optimizations and some architectural considerations. So first off, if your project turns into multiple projects, so if you got multiple teams working on maybe completely separate functionalities that might be built into completely separate customers, split out your shared module because once you grow to a size where you get all these teams working with you usually have built inadvertently or maybe on purpose a component library, and split that out into a separate npm package and publish it in a private repo. That way you won't step on each other's toes as people update the shared modules and make breaking changes and so on. And you'll be able to include the module like any other module in your project. And also use Codelizer to enforce best practices. This is really good, especially if you have some coders who just hack things until they work. It's really good to give them a bit of a limitation in that sense. And of course, once you've finished developing and you're maintaining your solution, configure some size budgets in Angular JSON. You can do that for all kinds of granularities, for style sheets, for files, for bundles, and so on. And also remember to lazy load all your feature modules, and do not easily load anything from the module elsewhere. Make sure that Angular is tree shaking unused functionality. It's a good idea to look down into the generated bundles and make sure that the service, for example, that no component is using is also being tree shaken properly. And if you're running an older project, you should upgrade to Angular 9. They are promising faster build times and improved payload sizes, so smaller bundles. And if you're really running into some very large, if you have some very large trees of components, then also optimize the change detection, because it can really make a difference in not having to go through every single component to check if something has changed. And finally, you can also tweak the build parameters in Angular JSON, but it is so well optimized that there's usually not much to come to get out of that unless you really know what you're doing and you really see something that's being done wrong. So let's just see if there's any other questions. Yes, the video should be available after this talk. Is there more structure control in Angular than React? Yeah, I would say so. There is a lot more. You're a lot more confined in a good way in Angular. As React is really just it's not the Wild West, because Angular really enables you to do a lot of things really well if you do them really well. But yeah, I would say Angular has a lot more structure than React, which is both good and bad depending on how you see it. And yes, I use Visual Studio Code. So how do you maintain the flat structure when the project gets larger? Well, you can sort of maybe take some larger features, some larger feature areas that cover maybe a lot of smaller feature areas, and then push this into separate folders. This is I'd say if it becomes unmanageable, you probably have a lot of features. But I would say just sort of make some larger feature areas in that way. But in the project I'm currently working on, we have about 50 different pages, and it's still manageable to have a very, very flat structure. And it's not really, you don't have to be forced into following this flat structure. You just it's just a recommendation, and as long as you stay as flat as possible, that's really the best thing to do. So I'll just show you some code here. I'll transition to the code view. So here we see a Visual Studio Code, and I've just created a sample app. The naming doesn't really follow the style guide conventions for those of you that are familiar with those. But as you can see here, I've created a shared folder for shared functionality. That could be a button or a type ahead component. And each of these components have their own folder. And then we have two feature modules. We have our TT example module and our TT preload module, which are then in the same structure here. And these things are then, if you look into our app component, which is what is being rendered to start with, you see we have 3 links to different routes, and then a router outlet. So if we look at the routing module, you can see that we use this load children functionality that I mentioned earlier. We import these modules using the import syntax, and then subscribe to this. And once it's loaded, we show this module. So while it's loading, it doesn't show anything. But then as soon as it loads, it fills out the router outlet with this module here. And also some smart stuff. You can actually also consider preloading your modules if you know that something is going to be used later on. So if you know that the user goes to this path TT, that they will 99% of the time go to this TT preload route, then you can actually preload that by providing your router with a preloading strategy. So I've provided this with a custom preloading strategy service. So what this does is it goes through every route that you've defined in your router, and it returns a preload observable. So what I do here is that I look at the route, and if it's the TT preload route and you're on the TT URL, it'll load that. And of course, if you're not on that route at load time, then you also have to hook into the router events and make sure that if the user navigates to there from some other part of the app, it'll also load the preload. So if we if I'll just switch into Chrome here, you can actually see this in action. So here we are at the root of the of this application, this very simple application, and you'll see that if we go into TT, it'll load both the example module and also the preload module. And if we try to reload the whole application here, and we go into some other route, which is also our TT module but a different route, then it won't preload our TT module, our preload module. So it'll as you look down here in this network section, you'll see that only now does it load the next module. So let's see if there's any questions here. So Kadir, you mentioned in many websites you can read that React's ecosystem makes React consider the framework. Can you mention how the ecosystem is built? Yeah, I'm guessing you mean that due to all the sort of libraries that you have to sort of use to make React functional in any classic application. Yeah, I would agree that you could sort of call this whole thing that you build yourself a framework. You usually, I don't know what you mean by how the ecosystem is built. Can you clarify that? So that was sort of an an introduction to how you can structure an application, how you can then do lazy loading, and then the syntax is pretty easy once you get used to it. But there's a lot of fiddling with things in Angular, and a lot of documentation to get right. It is, in my opinion, in my experience, much easier to deal with in React. So now that we are moving on to React, setting up React is just as easy as the Angular command line interface. You have exactly 3 commands as well. You install the CLI, you generate the project, and then you run the start command, and you are started. There's no official React style guide as mentioned earlier, but I find that a lot of what applies to Angular can also be applied to React. So using the lift principle and sort of the folder structure you get from Angular, you can sort of achieve some of the same things. Usually you're building, usually the argument for React is, especially with smaller applications, that you're building them with React. And if you're building a smaller application, it doesn't really make sense to really go into this whole big folder structure deal. But if you know that your application is going to be medium to large size, then it's really good to just use these suggestions from Angular style guide. So you make the structure as flat as possible, make the code easy to locate, and try not to repeat yourself. And React really helps you a lot. It gives you a lot of tools to actually avoid repeating yourself. For example, with higher order components. And you want to isolate your data fetching into services, same as in Angular. It's really common sense stuff, and I think React documentation could really use just having this common sense stuff written out for the developers. And of course, you need to think your architecture through from the start in React, because you don't have this confinement that you get in Angular. So you're much more free to just write out stuff, whatever you want, and then you'll only, as you reflect and look back on your on the application you've built, only then will you see sort of where you can optimize things. So for example, the contexts provide some global data on those to start with, if you know you're going to use them, and make sure that you know that you're going to use it, so you don't have to go through every single component and remove that context or rewrite it. And remember, avoid repeating yourself by using higher order components. We use a couple of those in the project I'm on right now for almost every single component. And also refactor often early on. That's also probably, that's a common sense approach for almost any endeavor when coding, but especially in React, you should refactor early on, as often as possible. So I've written here a proposed folder structure. This is also a folder per feature structure. You have one main component per feature that ties all the underlying components together. You split up your services, data, and components, and you have this core and shared folder as you saw in the structure for Angular. And then you split up the component folder into additional feature folders if your feature grows. One thing you'll notice is that a component here doesn't have its own folder. You could argue that you want its own folder, but in my experience, you don't really have that much stuff around the component that you do in Angular. In Angular, you, as you've noticed, if we just go back here, there you see these bars. Doesn't mean that it's one piece of it's one file. It's 1, 2, 3, 4 files for creating a component. You have your test spec, you have the styling, HTML, and TypeScript. While in React, you can get away with just writing a single component, or maybe a CSS module if you want to style it. So that way you can actually maintain an even flatter structure in React. There's also one thing that I'm a really big fan of in React, and that's the higher order components. These higher order components allow you to avoid having to repeat component logic that might just differ by a few parameters. So for example, this example here on the right, you have some data source that you then handle the changes that you subscribe to when the component mounts, and you unsubscribe when the component dismounts. And then you sort of abstract away this fetching, this subscription to the data, and in each component you just you get a data source that you then get the data that you want from it. So that way you avoid writing all this code in each of your two components. I've also done this for the project I'm currently on. We use it for query parameters, where we'll provide a higher-order component with an object that is all the query parameters that we expect for that page. And then that way we don't have to manually retrieve the query parameters each time we load a page, but we just sort of let this functionality do it for us, and then export the component out. And then that way you can also make the component expect that you get some query parameters and it's these specific objects. I guess I can show you the code actually. We'll just transition over here. So this is with query params, and this is with TypeScript, and TypeScript does not make it easier to write the higher order components. It makes it really, really hard. But as you can see here, you provide some query parameters, and you parse the query string from your location. So we're also using React Router. So you parse the location from your query string, and then you enrich this query params object with the fields that match the query string names, and then you merge these properties in and throw them into the component. So the component expects this query params object, and it'll actually be type safe. So you'll be able to have a strongly typed some strongly typed query parameters using this, and you really don't you avoid having to manually parse in every single component. And there's a lot of examples. You can do this a million ways as well. I'm sure you can do this with context too, if you want a more general approach to it. But this is just another example of how you can avoid repeating yourself in every single component. So also inject global data with context. This also comes from as I've formerly only been working with Angular and sort of moved towards React, and this idea of injecting data with context, it sits well with me. So I've been used to the dependency injection in Angular, and it's sort of the same here. So you create providers for global data like a user object. So the user object is the same everywhere, or a text resource file, for example. And of course, you can implement some Angular-like dependency injection using context if you really, really wanted to. And of course, you can also achieve this with Redux. So code splitting and lazy loading in React is, in my experience, much simpler and easier than in Angular. As you see here, you create this component. So you have a home component and an about component, and you import this using the same syntax as we saw in Angular, but you wrap it in lazy, which then returns a lazy component in React, which you can just render like any other component, as long as you wrap your router in suspense. So the router here is just React Router, which is pretty much the standard thing to use in React. So what you do here is that as long as it's loading, it'll just show your fallback component. So here it's just some div that says loading, and then once it's finished loading, it'll show your component. I find this syntax much more intuitive and much more concise than Angular, and it really makes code splitting very, very easy. And of course avoids re-referencing your lazy loaded components in an eagerly loaded part of the application, because then it all defeats the purpose and you'll have to load this the component anyways. So actually on my current project we have a very large code base, around 125 to 130,000 lines of code, and without a code splitting, a very simple page would load about almost 3 megabytes of page specific code and 3.5 megabyte of dependencies. These were, for example, we had over a megabyte library for Excel that we would use in 2 or 3 pages. So after setting up lazy loading for the heaviest libraries, and we did a route-based code splitting, the same page will load 32 kilobytes of page specific code. So you wouldn't have to load every single other page in your application, and we had cut down the dependencies to a third. And we can, with us a bit of effort, we can actually, I would say, we can bring this down by at least 40% as well, by splitting out some of our other large dependencies, and some of the we use OpenAPI, which generates a lot of services, and if we split those up into multiple packages, we could sort of say we don't need to load all the RESTful services. We only need to split up. If we split up the OpenAPI by feature, we would only need to load exactly what we needed. Remember, be aware of code splitting and lazy loading as well, because your application can grow really, really large, and you might not notice it on your really fast development computer with really, really super fast internet, but the users will complain, especially if you're serving stuff to users with slow internet connections. This was an internal system for use with pretty good connection. So this large chunk of dependencies wasn't really an issue, but it still affected the loading times as well, like the parsing all the scripts here, and executing them would take a noticeable amount of time, enough that our customers would actually complain. So some other tips for scaling your application: consider splitting out the shared components into a separate npm package if your project turns into multiple projects. And you should actually be building your shared module as if it was a component library that you'd want to reuse, because it'll just make it easier to work with in general. And this is just my opinion, but I would say use TypeScript from the start. Higher order components become a bit more complex to write, but it is possible to write them. And some breaking changes will be caught by the type system rather than just at runtime. And of course, use CSS modules, so you can isolate styling on single component level, so you won't run into either having to use BEM style CSS or just running into conflicts all the time with some developer who adds a new selector which breaks everything. Performance optimizations, other than code splitting, you can identify performance issues using the DevTools profiler. React actually has a plugin for Chrome, which lets you see all the timings the same way you see other JavaScript execution timings, and you'll see warnings for components being re-rendered too often, or if you fire a render cycle while the component is mounting, it'll also warn you of that. And of course, use should component update if you want to avoid re-rendering a component if the props or the state changes, but you don't really need to. You can ignore those props or states. So the next slide is probably the slide that a lot of people have been waiting for, especially the fanboys of either side. So I'll just look at some questions here before moving on. Do you think that Angular adds a lot of overhead compared to React? And if you do, how big do a project have to be before using Angular? Yeah, I would say there's a lot of overhead, and I think I'll come into how big a project has to be before using Angular in the following slides. Do you use Webpack? There's a reason that you use the arrow function in the screens that you're using. I'm guessing you mean the function component. You could just as well use an arrow function. And yes, I use create React app, which is sort of the standard suggested tool to use when building an application, which will let you polyfill all this stuff, and it'll bailify the arrow function into something that IE11 can understand. Let's see, Tom Quast says, personally, I think lazy loading is often not worth it. If you can cast to web application, it doesn't need to be lazy loaded. Yes, I agree. If the bottleneck is the network, I completely agree that it doesn't really make sense to lazy load. But I found, for example, with this behemoth of a framework that we had for, or behemoth of a library that we had for Excel, that it would actually affect the load times noticeably. To have to load this whole library that we didn't actually use anywhere. And I think you'll also see that if you grow really large, that it'll actually you might not have the script execution be the bottleneck rather than the network loading. How do you feel about a smart DOM component structure in Angular? I'm not familiar with that, but if you can send me a link, I'll try to look into it and answer you later. So React versus Angular. I on purpose made sure to call this thing React and Angular because I want to display the good sides of each library / framework. And I have to say there is no clear winner. It really depends on your team, on your architect, your prior experience, and so on. If your whole team has worked with React for a long time, it doesn't make sense to shift to Angular and vice versa. But we can look some of the there are some parameters that you can look at. A lot of people mention the learning curve, and I would say Angular has a much higher learning curve since it does way more. And you might, it's more the exception than the rule. You might run into some stale Angular documentation, which doesn't really help with the learning curve because now you have to look into the actual code to find out how something works. On the other hand, React leaves it up to you to figure out the libraries you want to add. And there's not really much to learn to be able to call yourself a React developer, but you still have to learn about the whole ecosystem. And in that way, there's also a learning curve. But getting started and using React, especially if you have a good architect or a strong front-end lead developer who can set up everything for you, when you then work with this guy, it'll be much easier to get going with React than with Angular. So in conclusion, I would say it's easier to get started with React than with Angular, especially for small applications. So I'd say the winner there is React. It's really much easier to get started and create a solid application using React. So performance and scaling, I'd say both Angular and React applications can be built to scale well from a loading / performance perspective. I would say it's easier to maintain Angular than React code as the project grows, just because you are sort of confined into this Angular way, which means that it's very uniform. The components you make, they usually act in the same way. The code is written in the same way. Whereas in React, you can sort of, you get a good idea when you're 20% along the way. Then you sort of, write your components in another style, and then you'll see that some of your older components might not look the same as your newer components code-wise. And React has historically beat Angular in both performance and bundle size, but Angular has really made a comeback with Ivy. These are some stats from some Angular's own blog, where they show that small applications and large applications get around 30 up to 40% size improvements by just upgrading from Angular 8 to Angular 9, and it does that by splitting out some functionality that doesn't have to load for each component. These are just some numbers from Angular themselves, so I couldn't really tell you what's really behind it, but give Ivy a go if you're on a lower version, or consider it at least if you're considering moving to Angular but you're scared of the big bundle sizes. They've made a comeback in that regard. So here I'd say, yeah, historically React is the winner, but Angular is really coming up on React in regards to performance and scaling. Although I'd say it's a bit more intuitive to optimize for performance, or it's a bit more easier, nicer looking when you're optimizing for performance in React than in Angular. So CLI functionality, it's sort of the same. So helping the developer build new components. Both of these CLIs let you set up a project with 3 commands, which it's never been easier to make an application with React or Angular. I'd say Angular CLI has templates for everything in the whole Angular ecosystem, or in the whole Angular, it's the framework's ecosystem, and you can even make schematics, so you can actually make your own, you can integrate your own templates into the Angular CLI. While in Create React App, it just sets up the project and gives you some build commands and some other commands that you can run to use. And you don't really need more than that. As we saw, like a component is really easy to make. Although I would like to see them maybe have something to build like a class component if you need something big like that. And it's also there's some pet peeves are that I'd say Angular CLI is much more often updated. Create React App releases about once every 1 or 2 months, and for example, recently since December and all the way to February, the development mode for Internet Explorer 11 was just broken. So they came out with a fix in January, where they fixed one issue, but that just meant that something else became broken in I11. So and now now we're waiting for some high severity package issues, package vulnerabilities to be fixed. And I think that Angular would be much faster to address these things, as they release almost every week compared to Create React Apps, a bit slower release cycle. But the 2 campaign line interfaces really just do what they set out to do, and they do it pretty well. But I'd say it's really like currently there's really not much difference, other than Angular CLI having a bit more functionality because it's a bigger framework. So the community and the popularity, if it was a popularity contest, React would win any day of the week, any month of the year. As you can see here, React has a much larger community than Angular, at least in the open source community. You just looking at npm stats, there's 53,000 npm packages that depend on React, versus 10,000 for the Angular's core. And Angular has fewer contributors to the Angular GitHub than React, despite having even more functionality. And if you look at the downloads in the past year for React and Angular, you'll also see that React is just much more used, and you'll also be able to find much more help when working with React and with Angular. So in that sense, React has a much more thriving community, and I'd say much less chance of becoming a dead framework in the future. But I don't think that Angular will die in that sense either. So I'll give you some pros and cons for choosing Angular versus React. I'd say you should choose Angular if your project benefits from this module-based architecture, if you have very large applications, and if you have big teams with inexperienced developers. I find that the restrictions that Angular puts on your inexperienced developers, I know we're all talented people who write really good code, but if you're new to it, it's good to have these restrictions in Angular that won't frustrate your colleagues, and once you learn them, you sort of become really efficient in it. So if you have to manage a big team, I'd say restrict them with Angular so they don't, code in every direction. And if you're building a small or middle-sized application, consider going for React. If you don't like this omniscient Angular way of doing everything, if you don't like the way that you have to implement forms in their specific Angular forms way, then go for React. If you have some experienced front-end developers, especially if you have just one or two strong React developers who can drive the architecture and make sure that it's solid, you can also get a really solid project out of it, even with some inexperienced developers. And of course, you have to have the ability or the vision to build a solid architecture early on, and not only just having a good folder structure, but getting the right libraries in, building the right higher order components, building the right services, and so on. So these are not like, if you're building a big application, you shouldn't not select React. So these are just reasons for selecting it. It shouldn't be the inverse. So if you can build a very large application with React, there's really nothing stopping you from doing that. And you can also build really small applications with Angular, as we saw with Ivy. The small applications actually have a much reduced size, and I think Angular is right now competing in bundle size with React. So we also had the question, how big should a project be before going for Angular? I can't really give you a good quantification of that. I think it should be up to sort of what you think, and I think maybe look into both of these frameworks / libraries, see what they can do for you, and then compare that with the requirements you have. These are just some heuristics. This shouldn't be hard and fast rules. These are just heuristics to decide the right framework. So I love both frameworks, although I love much more the freedom you get in React than you get in Angular. So that was the presentation. Let me just see if we have any more interesting questions. And I'm sure I've stepped on some toes of either people who love React or people who love Angular. So let's see what people are saying. So Tom Quast says, I would argue it is harder to learn React since there is no right way to do things. Angular, being opinionated, tells you what to do, although you might not understand it yet. Yes, that is. I completely agree with that opinion, and that's also what I've been trying to say. That yeah, it's harder to learn React, and you can learn React your own way. You can learn React the wrong way as well, and mess things up really really badly. So yeah, maybe it is sort of equal on the learning curve. It also depends on the scale. You can write some really really crappy React code for a small application, and you'll be good and go faster than having to do it in Angular. Would software engineers be hired for React / Angular projects? I think the stats that I've seen, it's sort of a dead heat between React and Angular, so you can get a job with either of them. I think React will probably be on the way up, as it already is. So I'd say go with what you would enjoy working with. If you have to decide whether learning one or the other for then go with what you would love to work with. If you are frustrated by the Angular way, then go with React, because there's really your well-being is probably has a bigger impact than the job offerings, which are pretty equal, depending on the country you're from, of course. If you're from China, go with Vue instead of either React or Angular. Let's see, any other questions? BBK asked here, do you think that Angular adds a lot of overhead compared to React? And if you do, how big does a project have to be before using Angular? I would say, yeah, Angular does add a lot of overhead, but if that overhead isn't really a problem at the scale you get up to, then it shouldn't really be a problem. And the overhead isn't there just to be overhead; it's there to sort of help you out. Mads Rosenberg asks, what about state management? Do you utilize extensive libraries in your projects? No, in the project I'm working on, we haven't actually used Redux. It hasn't really been necessary yet, but it's also we started out with a vision of having as few libraries as possible, which of course ended up in almost the opposite, as you saw with this big lump of dependencies. Um, I would say a lot of people love Redux, so definitely look into it if you're going to work with a React app. But it's not really necessary for building even a big React application. Um, would you say that inexperienced developers, as e.g. students, who should start learning React due to its less complexity compared to Angular? Hmm, depends on the learning goals, but I'd say it's easier to get started quick with React. So if React is sort of just a tool to get you moving on to some other parts, if you're doing a stack where if people are learning to develop a full stack application, then I'd say go with React. Um, because it's just easier to set up and it's easier to write some code quick, as opposed to having to learn the Angular way from the start. So I've got a question about licensing and main sponsors. Well, I wouldn't say that the sponsors are any big concern in setting up a project. If anything, having the sponsors and having people at Facebook for React and Google for Angular working on maintaining the library means that there are people who are being paid to actually make sure that what you're working with works. So I wouldn't say it's much of a concern. And if I recall correctly, the licenses shouldn't be a problem either. So that's about it. That's the hour over. I'll just stay here a bit for a few more questions if you have any. Otherwise, thanks for listening to the presentation, and thanks for participating in the first virtual tech talk from Netcompany. As you can see, I'm streaming here from my own apartment, as we're all staying inside. Could I recommend some good sites and courses to start to learn React? Honestly, just go to reactjs.com, reactjs.org, and just read the documentation there, either the docs or the tutorials. If you really enjoy having some teaching, then I can't really help you, but I'd say you can actually get really far with just the documentation. If you don't use Redux, how do you handle cross-component state? If it's in a page, I would just send down the properties that are relevant from there. But other than that, use contexts to sort of send down state to each component. But in our in the project I'm working on currently, we actually don't really have so many cross-component state concerns, so we don't really have a need for Redux. And thanks for all the really good questions, Tom Quast. You're really pushing me to the ropes in sort of my knowledge for these things. So yep, thanks for coming in. you can see my email here. If you have any questions, send them my way. And thanks for all the participation. Thanks for all the really good questions. Another question here. Did you observe in your project a clear difference with the maintenance efforts between those two frameworks? Let me think then. That's a really good question. I would say for React, there was a lot more revisiting the structure, the way we did things. We had to revisit that a lot more often in the React project I'm working on currently than I have had to do with Angular. Although I would say once you get to the maintenance level, it sort of becomes the same-ish. So I wouldn't say there's much difference there. But I would say personally, I feel like I work faster in React than in Angular. So it's sort of a trade-off here, you could say. If you start your new project now for a complex project, which one would you select? If it was something, if it was a project where you would have to, for example, build multiple, for example, have multiple builds and having a big system of, for example, separate packages and all that kind of stuff, I'll go with Angular, just because this module-based architecture gives you a lot of control that isn't as intuitive to work with in React. But if it was just one big application, then it would be a dead heat. I would look at the people I'll be working with, but I would probably be tending towards React, but that's on a personal level. The considerations to select one. That's again depending on the functionality that you have in your project. And I'm trying really hard not to say one is better than the other, because I'm sure a lot of people will swear by Angular and a lot of people swear by React. So yeah, I think there's too many variables to say in a definite way which library or framework I would use. And I know that's not really a good question, a good answer to your question, but that's all you're gonna get. So other than these, of course, the things I covered in the presentation about the complexity, but yeah. Do you have any experience with Vue.js and how it compares to Angular / React? Yes, I did work shortly on a Vue project actually. I would say it's pretty easy to get into. I didn't work on it from the start, but as someone who came in to do some maintenance and some bug fixing, it was really easy to get into. And despite the sort of a bit more bare bones functionality, it's really easy to work with. So consider it. Some funny things is I would run into if I looked for some issues on their issue tracker. A lot of them would be in Chinese, for example. That wasn't really helpful. I guess if you want to make some really performance stuff, then you can. I guess you can benefit from the much reduced bundle size of the Vue framework. but I can't really give you any detailed comparison with Angular and React. Any thoughts on the appraised svelte coming up? Yes, I've my experience with that is filling around with it in a stack blitz once. So can't really give you any intelligent thoughts on it, but it's even you know even thinner than Vue, if I recall correctly. Um, and I'd love to see it applied in a big project. And if it can sort of scale up well, then I'd be really excited for it. I really love working with performance, with loading, and sort of cramming as much code into a smaller bundle as possible, or as much functionality into a smaller bundle as possible. So I'm really excited if Svelte can deliver on that front. But yeah, definitely look out for it, and maybe I'll look into writing a small application in it just to see how it compares to about a year ago when I last looked at it. Are there more tech talks planned? I think there are some. I think some of our Polish colleagues will be doing one later. Although I'd watched the Netcompany LinkedIn, Facebook, and all the other social media platforms. Keep subscribed to those, and we'll post up some more tech talks. But definitely, there's going to be more tech talks in the future. This isn't the first one. It's probably not the last one. All right, guys. I think that's it for the tech talk. Thanks so much for asking all these great questions. I'll definitely look at Svelte. Thanks for the suggestion, Mass. Um, and stay tuned for more tech talks in the future. Could you say something about working for Netcompany? Only good things. It's really a great place to work. You get a lot of responsibility from day one, and they put a lot of responsibility into your hands. Uh, of course, like this tech talk, I pretty much had the free reins in how I would work with it, and how I would do the streaming and all the live coding and so on. So I'd say if you like having a lot of responsibility and then sort of working in a really nice place, and yeah, you should definitely join Netcompany. You talked about overhead in Angular. Any specific things you want to mention here? I would say the overhead. I wouldn't say it's unnecessary, but the overhead is in for example the component decorators and having all these files for providing a component, which you don't really have in Angular. Um, and it's pretty um, what's the word, uh, verbose to work with, which can be both good and bad. But the overhead is there for a reason, and it provides you with a lot of powerful functionality. Um, so yep. Anyways, I will end the stream now. I'm sure there's going to be a lot more questions coming in if I keep waiting. But thanks so much for staying with me and for listening to this tech talk.